In this tutorial, we're going to take a look at answers for a derivatives test, and this is for the MCV4U Calculus Vectors course in the province of Ontario, Canada. MHR stands for the initials for the publisher of the textbook, McGraw-Hill Ryerson. And this is actually the Unit 2 review on derivatives. So first of all, some multiple choice here. Which of the following is a common symbol for the derivative? And the only common symbol for the derivative here is the dy dx symbol. This is just a function notation. This is kind of close, but the prime would actually be in there. If we get rid of that prime and put the prime here, that would actually be a symbol for the derivative. And x prime is not a symbol for the derivative. X is normally reserved for the independent variable. So we often write functions in terms of y, and so in that case it would be y prime for the derivative. For the second one, what's the derivative of y equals negative 3x to the 7? So the 7 comes down and multiplies by the negative 3, which would be negative 21, and we reduce the exponent by 1 to 6. So C is the correct answer here, negative 21x to the 6. For number 3, what's the derivative of y equals the cube root of x squared? Well, I'd want to write the cube root of x squared as a power first. And remember, the 2 is the power, and the 3 is the root, so we put the 3 in the denominator. So the cube root of x squared is the same as x to the 2/3. So now I'm going to use the power rule, so that 2/3 is going to come down in front. So we write 2/3 for the derivative, x to the power of, and the way we get the exponent is we subtract 1 from this exponent. So if you take the 2/3 and subtract 1, now 1 is the same as 3/3, then that's going to be negative 1/3. So this would be negative 1/3 here. Now I always like my students to rewrite with a positive exponent and a root instead of a power. So this means the cube root, the power of 1/3, and the negative means that cube root is going to be in the denominator. So that's the correct solution here. You see, there's the 2 and the 3, the 2/3, and then it's going to have the cube root of x in the denominator with the 3. Again, in the denominator because the exponent is negative. Question number 4. What's the derivative of f of x equals 3 over x to the 5th? Well, I want to write that as a power again, like the previous two questions. So I would start by taking that x to the 5th up on top here in the numerator, and of course when we switch that, the exponent changes sign. So it's going to be 3x to the power of negative 5. So next what we would do is take that negative 5 and bring it down and multiply it by the 3, and so that's going to be negative 15. And we subtract 1 from the negative 5 exponent, so that'd be a negative 6. And always try to write again with positive powers instead of negative. So we'll bring that x to the 6 down underneath the negative 15. Or y, it actually should be y prime here, I guess. So we'd have negative 15 over x to the 6, which is answer D here. Number 5, what's the derivative of h of t equals 4t cubed minus 7t squared plus 9t minus 1? Well, power rule with all the parts here. So the 3 comes down and multiplies by the 4 to give you 12. I guess I'll maybe write this below. So h prime of t, so it would be 12t, and then we reduce the exponent by 3, from 3 to 2, or by 1, so we squared. And then the 2 comes down and multiplies by the 7 to make 14. T to the first, again, reduce the exponent by 1, 2 to 1, and the derivative of 9t is just 9. Remember, the exponent here is actually a 1, so the 1 comes down and multiplies by the 9 to make 9. And, well, we would actually have t to the power of 0 when you subtract 1 from the 1. So you don't write t to the 0. It's not really incorrect, but t to the 0 equals 1, so that's why we don't bother write the t there. And so that's answer A here, 12t squared minus 14t plus 9. Notice that D is almost the correct answer, But see, because this is h of t, it should say h prime of t. This is f of x equals. So like this is actually the correct derivative, but this is the wrong notation here. Number 6, what's the derivative of y equals negative 6x the fourth minus 3 over the fourth root of x plus 11? So I want to write this as a power first. So and then we can do power rule. So here, for y prime, so the 4 comes down and multiplies by negative 6, so that'd be negative 24. And x to the power of 3. Now this negative 1/4 comes down and multiplies by the negative 3 in front. So negative 3 times negative 1/4 would be 3/4. So we'd have 3/4 there. And quarters. And I want to subtract 1 from the exponent. So negative 1/4. Now minus 1. 1 is the same as 4/4. So that would be negative 5/4. Here, negative 5/4. Now, again, negative exponent, so I want to write that as a root, and it's going to be in the denominator with the 4. So I won't bother writing the negative 24x cubed down again, but we have 3/4 here. Actually, we'll extend that across here. So the 4 means it's the fourth root of x. And the 5 in that numerator means that's the power. So that's the derivative part here. So it'll be negative 24x cubed plus 3 over 4 times the fourth root of x to the fifth, which is answer B here. Or sorry, I'm looking at the wrong one here. C here. So yeah, C is the correct answer. This one's kind of close, but you see that that's the correct root, but it should be in the denominator because the exponent was negative. So C and B are quite similar, but the root's supposed to be in the denominator. So that's why C is correct and B is not. And one more multiple choice in the top of the second page. And for this one, you're told that g of x is equal to p of x times r of x. So if that's true, then which of the following are both correct versions of the product rule to find g prime of x? And D is the only correct one, because in the product rule, so one way to do it is to differentiate the first function times the second, which is what that says there, plus, and then do the opposite, the first function times the derivative of the second. Because they're added, you can actually differentiate in the opposite order. You can write this part at the beginning and this part at the end, which is what this says. So this is still, instead of the derivative of the first times the second, it's the first times the derivative of the second function, plus, and then the derivative of the first times the second function. So you can switch the orders in these. C is incorrect because it says you're differentiating the two functions here plus the product of the two originals, so that's incorrect, which is kind of the same thing as done here. B and D are kind of similar, except there's a subtraction sign here. If this was a plus and this was a plus here, it would actually be the same answer as D. So that's B is close, but not quite. And you can't find the product of or the derivative of a product by differentiating the two parts and just multiplying. That's not the correct product rule. So D is the only correct answer here. On to part 2, and a little note here, on the actual test there will be 5 overall communication marks for part 2 of the test. That's for showing proper mathematical form, using correct units when necessary, that kind of thing. So in part 2 here, we're asked to use the derivative rules to find the derivative of each function, and it says simplify each completely, and like the multiple choice above, leave answers with positive exponents only. And you should do radicals instead of powers too. That instruction isn't there, but that's also considered a better mathematical form. So in A here, m of x is negative 10 over 3x to the fourth minus 7x cubed plus 5. So I first want to write this as a power, so I can use power rule. So that x to the fourth is going to come up and be x to the negative 4 multiplied by the negative 10/3. And so now notice that's m of x. That's still the original function. It's not differentiated yet. So here's m prime of x, the derivative. So the negative 4 comes down and multiplies by the negative 10/3. Well, actually, I'll actually do the derivative of this first, and then we'll multiply it in. So derivative x to the negative 4 would be negative 4, and then we reduce the exponent by 1, so x to the negative 5. The derivative of negative 7x cubed, so 3 comes down and multiplies by the 7 to give you negative 21, and reduce the exponent by 1 to 2. 5 is a constant, so its derivative is 0, so there's no 5 here anymore. So now we'll multiply the negative 4 by the negative 10/3. Negative 4 times negative 10 is 40. 3 is in the denominator. Now remember, we're multiplying fractions here, so you could think of that as being over 1 if you wanted to. And then 3 times 1 is 3 in the denominator. The x negative 5, write it down in the denominator with a positive exponent, so it's 40 over 3x to the fifth. And then we have our negative 21x squared on the end. For B, g of x is negative 2x cubed times this binomial minus 4x squared. And you actually could use product rule here, but it would be longer. You could just expand, that's what I'm going to do, with the 2x negative 3 into these sets of brackets and then collect like terms. So 2 times 4 would be 8. Remember, we're multiplying powers of the same base, so we add the exponent. So negative 3 plus 5 is 2. And then also multiply the 2 and 2x to negative 3 into this term 2. So 2 times negative 5 is negative 10. Adding the exponents, negative 3 and 4 add to 1, so that's just negative 10x. And then we have the minus 4x squared in the end. Now that term and the 8x squared are like terms, so 8x squared minus 4x squared would be just 4x squared. And then we have minus 10x. I noticed one minor mistake I made here in the second line. This is supposed to be the derivative, so let's put a little prime here. So g prime of x, we're differentiating, so 2 comes down and multiplies by the 4, so it'd be 8x. And then the derivative of negative 10x is just minus 10. So that's the g prime of x. Now on to C up here, and I deleted the instructions because I didn't have room for them here, but you were asked specifically in this one to use the product rule. So y is equal to this product, so dy dx would be, and I'll differentiate the first function first, so 17 is a constant, so its derivative is 0. The derivative of negative 3x squared, so the 2 comes down and multiplies by negative 3, so that's negative 6x. Reduce the exponent by 1, times the second function, so that's the second function, plus, and then we do the opposite. So first function here, times the derivative of the second in these brackets. So the derivative of 2x squared would be 4x, and the derivative of 6x cubed would be 18x squared. Remember, 3 comes down and multiplies by 6 to give you 18, subtract 1 from 3 to make it 2. So that's the derivative, and now I'm just going to expand this in, these together, collect like terms, right, in a simpler form. So negative 6x times 2x squared would be negative 12x cubed. Remember, add the exponents. And negative 6x times 6x cubed would be negative 36x to the fourth. And then we'll distribute in here too. 17 times 4x is 28x. 17 times 18x squared is 306x squared. And then this product would give you negative 12x cubed, and this product will give you negative 54x to the fourth. And then we do some collecting like terms. There's an x to the fourth term here and here. Negative 54 and negative 36 is negative 90, so negative 90x to the fourth. And we have x cubed terms here, 2 negative 12x cubed, so that's negative 24x cubed. And there's only one x squared, and there's only one x term. So that would be our simplified derivative. For b, we have this function here, and the 5t divides evenly into all the terms. So why not divide that into those and then differentiate? You could do that quotient rule thing here, but it would be a lot longer than doing what I'm going to do. So 5t goes into 10t cubed, giving us 2t squared. 10 divided by 5 is 2. 3 minus 1 would be 2. Negative 15t squared divided by 5t is negative 3t. And 25t divided by 5t is just 5. So that's still b of t. It's not differentiated yet. So b prime of t, derivative of 2t squared would be 4t. Derivative of negative 3t would be negative 3. And 5 is a constant, so it's derivative of 0. So no 5 anymore. Now E here is chain rule. I'm going to use the chain rule because it's not just x to the fourth we're differentiating, it's a function of x to the power of 4 we're differentiating. So the chain rule goes like this. Now we're differentiating the outside function first, which is the power of 4 function. So that 4 is going to come down in front times the original function in here to the power of 1 less than 4 or 3. So that's the derivative of the outside function, and then we multiply that by the derivative of the inside function. Now the derivative of 5x to the fourth would be 20x cubed. Remember, 4 times 5 is 20. Reduce the exponent by 1 from 4 to 3. And derivative of 3x squared would be 6x. Now, it's generally considered a little better mathematical form to write the larger power on the end. So I put the 20x cubed 6x here. So I just rearranged from the second line to the third. So that I stuck in between the 4 and the bracket here. And there is a common factor in here. You could factor a 2x out of this. That's the common factor. So we bring the 2x out and multiply by the 4x, that's 8x. And of course, if I factor a 2x out of this, I get 10x squared, and 2x divided into 6x is 3. So I'm just writing in a factored form. And of course, this is still on the end. So that's the derivative. For question number 2 in the second part here, it says, consider the function y equals 4x cubed minus 3x squared plus 5. At what point or points do the tangent lines of this curve have a slope of 18? And here's a little hint. It says find all such points. Remember, the derivative gives the slope of the tangent at any point. So that's why I'm going to differentiate this function here. So the derivative of 4x cubed would be 12x squared, and the derivative of negative 3x squared would be negative 6x. No 5 anymore because it's constant. Now we want to find where the tangent line has a slope of 18. So I would set my derivative here equal to 18. Now this is a quadratic equation, so I'm going to bring the 18 over, so it'll be minus 18 on the left. And there's a common factor of 6 we can divide it all. So that's what I'm doing in this line here. So I'm going to divide a 6 out. So 6 goes into 12 twice, that's why there's 2 here. 6 goes into 6, well, there's negative 6 here, I suppose. There's actually a negative 1 here. And negative 18 divided by 6 is negative 3, so that's why there's a negative 3 here. And of course, 0 divided by 6 is 0, so that's why this is a 0 here. So let's get rid of all my hand scratching there. And we'll continue. So now this is the function we have to, or the equation we have to solve. So I'm going to factor. You could use the quadratic formula if you wanted to. But I'm using decomposition here. So there's a negative 1 here. So I'm looking for two numbers that add to that negative 1 and that multiply to the product of the 2 and the negative 3, which would be negative 6. And the numbers that do that are negative 3 and positive 2. So that's why I'm going to rewrite this, decomposing the negative 1x into negative 3x plus 2x. Now we need to do a little bit of factoring. The common factor in these two terms is an x. We factor an x out, we get 2x minus 3. And there's only a common factor of 1 here, so we just put brackets around the other 2x minus 3. So it factors out, and we get x plus 1 for the other factor. And we set each of these equal to 0. So 2x minus 3 equals 0, so we get 3 halves for that one. Setting x plus 1 equals 0, we get negative 1 for that one. So it seemed to be 2 points where the tangent line is a slope of 18. Now it says points, find all points. So that means x and y coordinates both. We have the x coordinates here, now we need to find the y. And you find those by going back to the original function. So in this, I'm going to substitute the 3 halves and then also the negative 1. So here's my little symbolism for putting the 3 halves in, x equals 3 halves here. So I'm putting 3 halves in here for x, and of course here too. Now, 3 cubed is 27, 2 cubed is 8, 3 squared is 9, 2 squared is 4, and I'm going to multiply the 4 by the 27/8. Now, I'm going to do a little reducing here. So I'm kind of looking forward to the fact that there's going to be a common number of denominator of 4 over here. So if I divide this by 2, I see if you could divide 4 into both 4 and 8, right? But I'm only going to divide a 2 out, just so I keep my common denominator. See, if I divided 4 into 8, I would get 27 halves, but I don't want to go that low because I want a denominator of 4 from this one. So the 2 times 27 is 54, and it would be over 4. And of course, again, if you just multiply that, 4 times 27 would work out to be so we would have 108 over 8, and 108 over 8, well, it reduces to 27 halves, but I want the denominator of 4 because I see this second function here is going to have a, or fraction, is going to have a denominator of 4. So if you multiply that top and bottom by 2, then you get the 54 fourths there. So multiplying the 3 by the 9 quarters, 3 times 9 is 27, so that'd be negative 27 quarters. And again, looking forward to getting a common denominator of 4, I take my 5 over 1 and multiply it by 4 top and bottom. And so that's where on the end here, I get the 20 quarters. So 54 quarters minus 27 quarters plus 20 quarters gives you 47 quarters. So that's the y coordinate for this point. We also put negative 1 in place of x here, so putting negative 1 in place of x, negative 1 cubed is negative 1 times 4 is negative 4, negative 1 squared though is positive 1 times negative 3 is negative 3, and plus the 5. So that's negative 7 plus 5 is negative 2, so that's the y coordinate for the negative 1 x coordinate point. So one point is 3 halves, 47 quarters, and then negative 1 comma negative 2 is the other point. So there's 2 points that have a tangent line slope of 18. For question number 3 here, it says, for a fair start in any race, each competitor should be at the starting line or behind it and should start from rest. The displacement in meters of a runner from the starting line is given by this cubic function here. It says where t is measured in seconds. So s of t is the displacement in meters, and t is measured in seconds. And in A, it asks to find the velocity and acceleration function. So velocity is the derivative of displacement, and so we differentiate s of t to get v of t. I could call this s prime of t, but it's the velocity function, so I'll use the terminology v of t. So differentiating the 2/3 t cubed. The 3 is going to come down and multiply by the 2/3, and then we subtract 1 from the exponent. Same idea here, the derivative of t squared would be 2t, so I'm going to bring the 2 down in front and multiply it by the negative 27 halves, and reduce the exponent by 1 to 1, and the derivative of negative 29t would be negative 29. 2 is a constant, so its derivative is 0, so the 2 is gone. Now, these 3's divide out to give us just 2t squared. These 2's divide out to give us just minus 27t and then minus 29. So that's the velocity function. The acceleration function is the derivative of velocity. So the derivative of 2t squared would be 4t. Again, power rule, so 2 times 2 is 4. Reduce the exponent by 1, so squared goes down to a power of 1. And the derivative of negative 27t is minus 27. And once again, negative 29 is a constant, so it's derivative 0. There's no negative 29 here anymore at all. Now, in B it says, when did the runner start moving forward? So if you look at the velocity, we want to find the points where the velocity is 0, and so, or changes from 0. So the only 2 times, well, there's actually going to find 2 times here, we'll set our velocity function to 0. And so setting that equal to 0 gives us a quadratic equation. I'm going to solve this by decomposition again. So I need 2 numbers that add to negative 27 and multiply to negative 58, which would be negative 29 and 2. So I'm going to decompose that negative 27t down to negative 29t plus 2t. And I can common factor a t out of here. And there's no common factor here, so I just put brackets around the 2t minus 29. So that's in common here, so 2t minus 29 is one factor, t plus 1 is the other. And so setting each of these equal to 0, if we set t plus 1 equal to 0, I get negative 1, and 2t minus 29 equal to 0, I get 29 halves, or 14.5 seconds. Now, so the velocity, the velocity of the runner was 0 at minus 1 second. So that means that the runner started to move 1 second before they were supposed to, before the whoever blew the whistle or whatever to start the race. So the runner actually started moving forward at minus 1 second, 1 second before they were supposed to. So this is kind of leading into questions about, did they false start or not? That certainly indicates that they did. C also asks, what's the runner's position at 0 seconds? So when the race was supposed to have begun. And so if you go back to the original function, this here, and put 0 in place of time, see, in order for it to be a fair race, they're supposed to start at the starting line or behind it. So if we put 0 in that displacement function, 0 here and here and here, well, that's 0, that's 0, and that's 0, but the 2 means that at time 0, the runner had already moved forward 2 meters. So they're moving before the race is supposed to start, and at a time of 0, they're 2 meters forward. So they certainly false started. So that's what D is actually asked to explain. They false started because they started moving a second before they're supposed to, and at the beginning of the race they're already 2 meters ahead of the starting line. And one more question about E. What's the acceleration of the runner at 6 seconds? Explain what the sign of this answer means about their motion. So this was the acceleration function from up here at the beginning. A of t is 4t minus 27. So at 6 seconds, we put 6 in place of time. So that's 24 minus 27 is negative 3. And the units would be meters per second squared. That's the unit for acceleration. Now, explain what the sign of the answer means. So the negative acceleration means the runner was slowing down. Their velocity was getting smaller. So after 6 seconds, they probably reached their peak velocity and they're starting to tire. So they're actually starting to slow down. So that's what the negative sign means about their motion. Question number 4. A company is selling maple syrup. The company claims the demand function for the product is P of x, the price function or demand function, is 2,000 minus x over 100. And the cost in dollars of producing x liters is this function. C of x is 75 times the root of x minus 10. And this is supposed to only be greater for producing 400 liters. More than 400 liters. So in A, find the revenue function. So revenue is the price that you're getting multiplied by the number that you sell. So it's x times P of x. So we take our P of x function here and multiply it by x. So multiplying the x, now remember x is the same as x over 1. So when you multiply the x, the numerator into the numerator, that'd be 2000x, and x times negative x is negative x squared. 100 times the 1 in the denominator, of course, is 100. And now I want to simplify my function here. So 2000x divided by 100, 2000 divided by 100 is 20. Okay, so that's going to be a 20x. And negative, well, there's a 1 there, right? So negative 1 divided by 100. So the coefficient of the x squared term is going to be negative 0.01. So that's my revenue function, and in B it asks to find the marginal revenue function. So marginal means we're going to differentiate this. So here's our revenue function, the derivative. So 2 comes down and multiplies by a negative 0.01 to give us negative 0.02, and we reduce the exponent by 1, so 2 becomes a 1, and derivative 20x would be 20. So that's the marginal revenue function. And C says find the profit function. So a profit function, profit is revenue minus cost. That's how businesses calculate profit, revenue minus cost. So we need the revenue function. So here's the revenue function here, substitute in place of the revenue function, minus that cost function from up here. Okay, so that's our cost function. So I'm going to multiply the 75 into the set of brackets here. So it'll be 75 root x minus 750. Remove the brackets. That minus subtraction sign means the sign's going to change. It'll be minus 75 root x, and this will be plus 750. So that's my profit function. Now, marginal profit function means the rate the profit's changing, so I want to differentiate my profit function here. So here's my profit function from the previous question, and before I differentiate it, I'm going to write the root of x as x to the power of a half. So that's my profit function. So the derivative, and you might not be able to see, there is a little prime there. Maybe I'll highlight that a little better. These are primes. Pretty hard to see there a bit. So the 2 comes down and multiplies by negative 0.01, so negative 0.02x. Derivative 20x would be 20. Derivative of 750, since the constant is 0, that's why there's no 750 here anymore. And the derivative of the x to the power of a half, so the half comes down in front and multiplies by the negative 75, so it's negative 75 halves. And we reduce the exponent by 1, so a half minus 1 is negative a half. There's a little negative sign right there. Now, the power of a half means the root, and the negative means that root's in the denominator. So that's why I wrote my root in the next line in the denominator beside the 2. So that's my marginal profit function. And E asks to find the marginal profit for producing 900 liters. And again, there's a prime here. You might not be able to see it very well, but there actually are primes there. There we go. So I'm substituting 900 in place of x. So 900 here and here. And of course, maybe we'll bring the calculator over here. Negative 0.02 times 900. Whoops, I goofed. 0. So, oh yes, I missed a 0, didn't I? Insert a 0 right there. There we go. So that's where the negative 18 comes from. The root of 900 is 30. And so secondly here we have 75 divided by 2 times 30. So that's the minus 1.25, and then plus 20. So negative 18 minus $1.25, this is money actually, plus the 20 gives us 0.75, which is 75 cents, or $0.75. So that's the marginal profit for producing 900 liters. Now, F asks to interpret the meaning of that answer. So marginal profit means the rate at which profit is changing. So if it's positive, that means that profit's increasing. So if you're producing 900 liters, or they are producing 900 liters, a marginal profit of 0.75 means that at producing 900 liters, the profit is increasing at 75 cents per liter at that point. If it was a negative marginal profit, that means their profit would be going down, and of course they wouldn't want to produce more because they were actually making less money then. And one more question here. This is the bonus. We're asked to differentiate this quotient. So WT is 8t minus 5t squared over 4 plus t cubed using the quotient rule. And so quotient rule, so here's my function, starts with the denominator, so the 4 plus t cubed, times the derivative of the numerator. So derivative of 8t would be 8. Derivative of negative 5t squared would be negative 10t. Minus, and now the numerator expression times the derivative of the denominator. So 4 is a constant, so its derivative is 0. Derivative of t cubed would be 3t squared. And it's all over the denominator squared. So the 4 plus t cubed all squared. So that's actually the differentiation done. Now I'm just going to expand these together and collect like terms to make my derivative a little bit simpler. And again, there are primes there. You see a little bit better there, but those are w prime of t. So 4 times 8 is 32. 4 times negative 10t is minus 40t. T cubed times 8 would be 8t cubed. And then minus 10t to the fourth here. And then I'm going to multiply the 3t squared in here. Remember that minus sign means I'm multiplying really negative 3t squared in. So negative 3t squared times 8t would be minus 24t cubed. And negative 3t squared times negative 5t squared would be plus, because there's two negatives there, 15t to the fourth. And so I have some like terms here. The 15t to the fourth minus 10t to the fourth are both t to the fourth terms, so that would add to, or subtract to, 5t to the fourth. And then I have a negative 24t cubed term here and an 8t cubed, so that would simplify to negative 16t cubed. And there's only one t term and one constant, so negative 40t plus 32 in the end, over the 4 plus t cubed squared. Now, if you want to expand that denominator, you can, but it's not necessary. Okay, it's in a little simpler form if you leave it in the factored form, so we'll leave the derivative just like that. And that's